Space St. Croix is just the name of our educational group, Space, because that's kind of the foundation for a lot of our educational programs to get kids excited about science, technology, engineering, and math through using space topics as kind of an entry point. And then St. Croix, because that's the name of the river that we live alongside here in Hudson. The St. Croix River is kind of the state boundary line between Wisconsin and Minnesota. And then I'll talk about my NASA Solar System Ambassador work as well. So what is Space St. Croix? A lot of people ask. I kind of just explained that a little bit, but these are some photos and some things we do in the community. I also advise the Hudson High School Space Club, which is the 9th through 12th grade students. And pictured here in the glasses is Tyler. She was president of the Space Club at the high school level about a year ago. And we do a lot of fun activities in the community. And this particular photo is when we went to meet Canadian astronaut Chris Hadfield. He was in St. Paul doing a book signing. He'd written a new book about his time on the International Space Station. And so the whole club piled in a van, and we went out to go meet Chris Hadfield and get to talk about his career, his advice for classes to take in school, and those interested in becoming an astronaut or working for NASA. Some tips on that. And then we do some public awareness campaigns. So the other photo here of the young gentleman is a Penny for NASA campaign we did just to bring community awareness to NASA's budget, which in our country, NASA gets just under half a penny on every tax dollar for their operating budget. So a lot of people are surprised by that when they hear that number, and a lot of the students wanted to do a penny drive where they're bringing their pennies to kind of raise awareness that if kids can give some pennies for NASA to help their budget, that maybe the politicians and the leaders could provide some additional funds to NASA as well. And then we do a lot of activities in the community. So here are just some of the photos of some of the programs we do. So up on the upper left, we work with some regional groups. This is the Minnesota Astronomical Society. So they're a group of astronomers that own telescopes, and some of them work as astronomers at regional universities, or they work in planetariums or other affiliated work, and they've banded together to help with outreach events, public events. So when I'm organizing a program at a school, I'll contact them, and so this is when they brought some telescopes out to one of the schools we were working with in Hudson to do a night sky event, an astronomy club. We were launching there. We do model rocket launches at schools. We started a model rocketry club at the middle school here in Hudson. So they are competing regionally in a state competition with other schools building model rockets. Up on the right-hand corner, we offer 3D printing programs. One is like a summer camp where the kids can design their own 3D capsule, space capsule, and we'll print it out on the 3D printer. They can make design changes based on how it performs. We'll do flotation and aerodynamics tests and wind tunnel tests and that. Make multiple designs kind of perfect their space capsule. And then on the bottom photo, I get the opportunity to, being a NASA Solar System Ambassador, to travel to a lot of the NASA centers and interview astronauts and engineers that work on a lot of the programs being developed and put forth. And so that's a great resource to bring kids in the community kind of a firsthand experience. A lot of places they may not be able to ever travel to, or people they may not get to meet. We kind of document and videotape and do interviews to bring that experience back to share with students. And then this is just some of the examples of the programs. On the left is one of our Mars exploration Mars programs. We were talking about the Perseverance rover that'll be launching in July of this year to venture to Mars. And then the other photo is when I got to interview astronaut Scott Kelly. This was about 2 months after he completed his year-long mission on the International Space Station. I got the chance to interview him. And that was another great experience to be able to share that with students in the community and ask questions that they had for Scott Kelly and share those. And then just an example of like a presentation we do, the International Space Station, the 20th year, a continual crewed occupation on the International Space Station. So that's one of the more popular programs we do at the schools. And then the member patch with all the member nations, their flags represented there, that partnered with the training of astronauts and running of experiments and developing modules, equipment for the space station. And then, again, in some of these trips, I get to take a lot of the kids these days don't have a lot of experience with the space shuttle since those all were retired in 2011. So this is a picture of me in Washington, D.C. I was at the Hazy galleries at the Smithsonian Institution, where they have the Space Shuttle Discovery on display parked there. So was including a photo of myself in front of the shuttle just to give the kids kind of a feel for how big the vehicle was compared to the space station, and get a sense of scale of things. The younger kids today really don't have any experience with the space shuttle, seeing the launches on TV or going back and talk about how that was kind of a workhorse vehicle for deploying instruments like the Hubble Space Telescope, and critical in building the International Space Station. So that gives the perspective on that. And then again, some of the interviews, I also got to interview Mark Kelly. So here, it was a little easier to tell Mark and Scott apart when Mark had a mustache. You can see Mark with a mustache here, but now he's shaved it as well. So they're identical twin brothers, and some of you may be familiar with, they did an experiment on the space station where when Scott spent his year on the space station, Mark agreed to be kind of a ground-based baseline for the science data they were gathering. So they would both get blood tests at the same time. Mark down here on Earth, when Scott was getting a blood test up on the space station, they both got flu shots at the same time. Their diet, exercise were being tracked. So being identical twins, NASA got a lot of invaluable data on what happens to your body on Earth over a year versus what happens to your body in a microgravity environment on the space station. So I was fortunate enough to, in the top picture, I got to interview Mark while his brother Scott was up on the space station. And as I mentioned before, I got to interview Scott about 2 months after he completed his year-long mission. And then on the side there, we have our social media stuff, the kids trying to stay engaged. I'll do a few visits during the school year, and then during the summer we offer camps and things. So try to keep the parents and the kids aware of our social media so they can always know when there's different night sky viewing events coming up, or when we have a camp coming up during the summer, or when we're going to be making our next school visit, things like that. So we found that's a very good tool to try to engage in as much social media as we can to keep people engaged and aware of being able to take advantage of the resources and programming that we're offering. And then another one that gets the kids excited, we're talking about lately, is the upcoming crew vehicles that will be taking astronauts to the space station. Because right now, any astronaut going to and from the space station needs to fly to Kazakhstan to ride on a Russian Soyuz to and from the space station. But later this year, actually next month, the vehicle on the bottom pictured there is a Dragon crew capsule launched by SpaceX, and that'll be taking 2 astronauts on the first crewed flight, the crew test flight to the International Space Station, scheduled to launch in May. And that'll be the first time in over 10 years that a crew vehicle is taken off from the United States. So the other vehicle up above it is the Boeing CST-100 Starliner. That vehicle's had a test flight. They're going to be doing another test flight because they had some issues with the first test flight, but that's another vehicle that'll be capable of carrying astronauts and crews to and from the space station. And then the winged vehicle at the top is the Sierra Nevada Corporation. They make a vehicle called the Dream Chaser, and there's a cargo version and a crew version that they make of the same vehicle, and they're going to be launching cargo. They received a cargo contract award from NASA, and they'll be flying cargo to and from the space station starting next year. And it looks kind of like a miniature space shuttle. It's able to be reused, reusable vehicle, and as you can see in the photo, it's designed to come down to a glide runway landing, much like the space shuttle did. So it'll launch on top of an Atlas V rocket, and those are slated to start next year. And the photo on the bottom is one we shared with kids and programs. This was the uncrewed test flight of the Dragon, where they had a censored mannequin, which is in the spacesuit there pictured, that had sensors all over it to measure the vibration, the sound, the G-loads that the astronaut would experience, just to verify that that all checked out the way they thought. So that's the way the vehicle looked when it docked with the space station. And all those tests went very well, but that's what the inside of the Crew Dragon looks like. It's designed to carry up to 7 astronauts. It'll just carry 2 on its test flight next month. That'll kind of validate that everything is indeed working well with the vehicle, and then they'll be able to take larger crew rotations back and forth. And a lot of kids are excited to see those new vehicles coming online. And then these next few slides are, again, just that bringing the experience to your community, to the students that they might not otherwise get to partake in. So this is me at the Johnson Space Center in Houston, Texas, where they have the neutral buoyancy laboratory, which you see here, which is a giant pool that they have, as you can see in these photos, that they have a full-scale mock-up of the International Space Station with all the modules and the truss there to practice spacewalks, EVAs, that they'll do beforehand. So the large yellow objects you see in the background, those are cranes where they can configure what's in the pool any way they want. They can move things around for a particular test. And then I'm pictured here with, this is Neil. He's one of the Navy divers. They assist the astronauts and kind of help move them from section to section because the pool is very good. When they get you weighted properly, you won't float up, you won't float down. You're neutrally buoyant. And it's very good simulation, the best we can get on the ground for simulating that microgravity environment. But the one thing it's not good at is if you're done with the job and then you're kind of moving from one part of the station to the other, pulling yourself through the water would not be at all like moving through microgravity. And it would kind of fatigue the astronauts more quickly. So they have these Navy divers, they kind of grab them under each arm and will swim them over to the next workstation, the next project they're doing to kind of keep that simulation going in the right way and not over-fatigue the astronauts length of the time of the EVA. So this is inside of that building that you saw me pictured on the outside of. So it's one of the largest pools in the world. It's about 50 feet deep. That's where they kind of simulate all the spacewalk training they'll do before they actually go do it on the space station. And then we talk about future programs coming up. This is one I'm very excited about. I'm sure a lot of you are familiar with the James Webb Space Telescope. That's the mission badge for it. Joint collaboration between NASA, the European Space Agency, and the Canadian Space Agency. Scheduled to launch early next year. That might be delayed a little bit, obviously, with the COVID-19 issues, but last update was scheduled for March of 2021. And then there's kind of an artist depiction of what the telescope looks like fully deployed. And this is another one where I was lucky enough to do a NASA social trip to the Goddard Space Flight Center in Greenbelt, Maryland. And that's where they were constructing the James Webb Telescope. I was able to visit there while they were installing the mirrors for the telescope. And then, again, shoot video and photos and document this to kind of bring this back my community presentations. So what I'm standing in front of here is one of the interesting spaceflight simulator. It uses liquefied helium. Right at the top of the photo is a hatch that's removable, and they can put whatever they want to test at the inside. So they would be testing components of the James Webb Space Telescope, putting them in there, making sure that they would be able to function properly in the deep space environment. So they seal the door, they'll put the instrument in, and then drop it down to about, as you see on the chart there, minus 270 degrees Celsius. When I was there, they were just wrapping up a test, about a 6-month long test. So they were doing a cold soak for some of the main bus instruments from the James Webb Space Telescope, and they were sending signals and asking for measurements back and making sure the communications worked, testing all the systems to make sure they would operate properly. And everything went very well in that test. Just to let you know, the length they go to. That was about a 6-month test just on that main bus communication data relay system for the James Webb Space Telescope. That was at the Goddard Space Flight Center, and then these are photos I took. They have a Pathfinder, which is their term for it's identical in construction to the James Webb Space Telescope, but it's not the real telescope. It's the exact weight and size and dimension of the telescope, but they can practice on this one anytime they're installing a component, they're making a change, they're tightening a bolt, they're adding a piece, what have you. They test it on this Pathfinder, and then if they notice any errors or problems, they can do further testing to kind of resolve that before they install that piece on the real James Webb Space Telescope. So it helps them refine their procedures, see any problems that might be coming up, write different instructions for how the install has to be done to the people that will be doing that. And they were working extensively on the Pathfinder while I was there. So they're kind of a few steps ahead of what's happening on the real James Webb Space Telescope. They're working on things that are going to be happening a few months down the line, real telescopes, so they can kind of make sure that everything's going to be proceeding on schedule and technically that it all work out. This is just more of that same room with the Pathfinder, so you see some of the hardware there they're testing, and they're working through the procedures and what will happen. Again, this is at the NASA Goddard Space Flight Center in Greenville, Maryland, where the telescope is assembled. And then this is one of my personal favorites. This is the NICER experiment package. You see behind me, that's kind of the orange box. And there's a plastic barrier right behind me. You can barely see it, but that's there's a person operating in a clean room environment there. I'm on the other side of it. And the NICER package is the Neutron Star Interior Composition Explorer device that was flown up subsequently to the International Space Station. So I was there when they were just prepping it to get it ready to ship out to the Kennedy Space Center, where it was going to launch on a Dragon resupply mission to the space station. We packed the trunk of the Dragon, and I was lucky enough to be there where they were just packing it up. And this is a photo of them kind of installing some of the sensors for it. And so it's mounted on the exterior of the International Space Station. It's a joint project between NASA, the Massachusetts Institute of Technology, Goddard Space Flight Center, and it studies neutron stars. As an X-ray telescope, does spectroscopy, studying dynamic phenomena of pulsars, and it was going to also do a X-ray navigation demonstration, and then study X-ray communication between spacecraft and space just to test the feasibility of that. So this is a little short film showing you how it can rotate track, because obviously the space station is traveling at 17,500 miles an hour. It's constantly orbiting the Earth 24 hours a day. So you can see the solar panels going by. The solar panels are designed to track with the sun to keep the chargers maximum power. And then you can see NICER here tracking on its motor head, where it can track on a neutron star and stay fixed on it for studying. But that's where it's mounted on one end of the station, kind of toward the solar panel assembly structure for that. So that's what was behind me there. And that's it, installed up on the space station. And then to show you, this is where they're located. NICER is, again, for those solar panels you saw rotating in the background. And XCOM is the other device they set up. This is the arrangement of the experiment to test X-ray transmission of much larger data packets than we can currently send. So they mounted XCOM on the one end of the space station, about 50 meters away from NICER that you saw previously. And XCOM would send an X-ray data packet. The experiments they're working on now is to kind of validate that that'll work for future spacecraft that might be going to the outer planets, space telescopes, whatnot, to send much larger packets of data much faster. Or not much faster, because it's still the speed of light, but you're getting much larger packets of information in your downlink. So that's kind of an interesting experiment that they're doing at the space station. And then I was going to talk about closer to home. These are some of the Galileo scopes that I use for, I received an educational grant to purchase these kits that are a lot of fun because you kind of see it's a 50 millimeter refractor telescope kit, 2-inch. So they're great. They are very similar to the dimensions of Galileo's telescope, hence the name. They're made here in the state of Wisconsin. They're a small portable kit, and they allow students to kind of learn how to put a telescope together. So this is the size of it compared to one of the students using it. So it's very close to the Galilean architecture for size of it. The kids can see the Galilean moons of Jupiter. They can see the rings of Saturn with it, just to let you know the resolution on them, great details on the moon. So I like that the kids can assemble them. They're a plastic telescope. They have directions for installing the different glass elements in them for the eyepiece and for the mounting screw for the tripod and that. So we talk about optics and lenses, and I like the kids kind of put it together themselves. It's not just this mystery of being handed a finished telescope, so they can kind of understand a little bit about optics, work through it, and then they get to take the kits home. I've got enough for a classroom of students at a time. There's a duffel bag for them with a tripod and a star chart, kind of a journal. And then the kids are given assignments depending on the weather for that week. They're told to go out and find certain targets and make their observations, keep their rules and come back. So I've also been able to donate one to the local library for a checkout STEM kit. And then, as I said before, we also try to partner on events with different astronomical societies. The closest to us in Minnesota, astronomical societies, and then they'll come out with their telescopes as well. And that gets the kids pretty interested in what's going on. So I think that's my last slide. So I can exit back out of this here. Okay, so I think I can open up to questions. That was most of the stuff I wanted to share. And I have a few of these that I can share up the screen. So as I mentioned before, we do some 3D printing. So this is the James Webb Space Telescope. So this helps a lot with answering questions on certain things when we can pass around 3D printed models, scale models of the spacecraft, so then the kids can kind of touch it, feel it, and point to what they have a question about versus just looking at photos of it. So working with NASA, I've also been able to acquire some things. There's five main sheets of Kapton foil that help insulate that the telescope is kind of oriented this way, facing the sun. So as to allow the infrared detectors to work at the optimal temperature. And those five kind of tennis court size sheets of Kapton foil, I have these actual sheets, sandwiches of Kapton foil. So that's another one where the kids can directly hold these packets of the same material that will be on the James Webb Space Telescope. Ask their questions and kind of understand the materials involved directly. And then we do a lot of other things, which we'll talk about later. We did a lot of 3D glasses collection from the last solar eclipse that we had here in the United States. We collected those we shipped to Astronomers Without Borders. So a lot of schools were receiving 3D eclipse glasses, and they weren't going to be using them obviously after the event. So I was able to coordinate with all the schools that have received boxes of these that I'd like to recycle them and send them to Astronomers Without Borders and share around the world for that. So that is what I had for my main program. I'm very happy to answer any of the questions or whatever else you'd like to talk about.
Thank you, Christopher, for the nice talk. I don't know if we do have question. Okay, for me, I got two questions from the page. The first is, does there any volunteer work that we can join with NASA? And the second question, how could some be ambassador for a specific NASA project?
First, I'll answer the last one first. For a specific project, usually if you can go on the internet or go to the NASA homepage, any project that's coming up or that you're interested in, we usually list the contact information of the media contact, one of the principal investigators on that website page. So like, for example, if it was the James Webb Space Telescope, you type that in, you go to the NASA page, and on that page, it'll list contact information, either email, phone number, a mailing address for some of the people that are handling that project. And that would be the way that you would initiate a contact to find out about being an ambassador for that project or working on something about that project. I think your earlier question about being a volunteer, I know every program is a little bit different, but if you want to Google NASA Solar System Ambassador, that'll take you to the homepage for the Solar System Ambassador Program. And there are ambassadors all around the world that do these kind of outreach programs. So it is an application process. There's a short application. They usually do a short interview by phone or by email, depending on the logistics or what work out. And then it's also dependent on the need they see in your area, or if there's already ambassadors that are kind of covering your area, sometimes they aren't looking to add necessarily. But that's just kind of the process. If you wanted to inquire about that as well, you can introduce yourself, reach out and say, I'm interested in being an ambassador, and this is where I'm from, and who I'd be talking to. Tell me if there's any opportunities involved out.
Mm-hmm.
Was there another part to your question, or did that answer?
Yeah, the first question was if there are like any volunteer work, so they should check the NASA website, right?
Yeah, I could say for specifically, if you wanted to Google Solar System Ambassador, that'll take you to the Ambassador homepage. And then if there's any other mission, Hubble Space Telescope, James Webb, International Space Station, whatnot, if you just went to that landing page, you would find the contact information on that page, usually at the bottom. Who last updated that page, or who the contacts are, the media contacts, or the principal investigator contacts are listed at the bottom of that page. That'll be the next step.
Mm-hmm. Thank you. So if someone have a question?
Yes. I have just one question for Sir Christopher Mike. Thank you for this lecture.
You're very welcome.
It's so interesting. I think it's like a kind of sharing this lecture. So my question is so simple. We're talking about STEAM, what NASA doing about a lot of program. I just asking if NASA or staff of NASA are interested to work in like a GTTP program for teaching, or for teacher who contact a lot of kids and a lot of students for giving more information about astronomy and use this resource in an online platform. If NASA thinking about this to apply like a GTTP program, Galileo Teacher program.
Okay. Again, I know NASA puts a lot of their information, it's just public domain and public accessible. So you can find a lot of resources just on the NASA website. As far as working with teachers, I know some of that is based, there's a requirement to be a U.S. citizen for receiving some of the program funds and that. So I don't know if that would be an obstacle to what you're talking about. I know with Solar System Ambassador, there are ambassadors outside of the United States. I know I get some NASA educator grants, out of school educator grants. And I know there's a stipulation that you need to be a U.S. citizen in order to apply funded with U.S. tax dollars. And so they do have to put in there that anything funded with U.S. tax dollars, only U.S. citizens are eligible to apply for those types of grants. So depending on what would be involved, there would be a cost for NASA to sponsor that for teachers, and for a program, there might be a restriction on them being able to provide funds as far as accessing any of the information that you'd want to put together for a program. Would be something that's just accessible off of their website.
Thank you.
Let me thank you, Dr. Christopher, for this fabulous meeting. I would ask you if I can work at NASA even I don't have the opportunity to be an American person. If I don't have the nationality, the American nationality, can I work at NASA? Thank you.
I know, depending on the research project or the mission that you would want to work on, I know there's, as I mentioned, with the James Webb Space Telescope, that's a partnership between National Aeronautics and Space Administration, the European Space Agency, and the Canadian Space Agency. And then mentioning all the member countries that were involved with the International Space Station and science research projects there. So depending on the project, there is a way for NASA to collaborate with other scientists and engineers and researchers in other countries. If that country is not directly involved in that particular mission, and it would kind of go to what I said before, where the information would be accessible, that's publicly shared, but any funding or exchange of resources, there'd be a restriction for a U.S. citizen for that.
That means it depends on my scientific qualifications?
It does not really depend so much on your scientific qualifications. It's more of what member nations are involved in whatever particular project. So if it's a telescope project like the Hubble Space Telescope, if there's several countries that have working relationships with the member countries that have put the Hubble Space Telescope together, there would be access for all of those scientists to submit papers or conduct research or to request time on the Hubble Space Telescope. They need to be affiliated with the program. So I don't know on everyone's end on their own countries if they have a scientific relationship or if they have a university nearby that has a relationship on one of these projects. That would be kind of the access point for finding out about collaborating, working on a project. Is usually if there's a university nearby that's involved in one of these NASA projects.
Yeah, I understand.
So, Christopher, do you have like any work or collaborative work with James Space Telescope? Like, do you have something to do with it, with this space mission?
I'm just kind of an outreach educator for it. So sharing some of the photos I took on my trip while they were assembling it. I also got to see as it was being loaded on an airplane when I was in Houston at the Johnson Space Center in Houston. So it's been kind of making its way around the country, being tested at different centers. So I'm not involved with the project. I've been able to go to some of these events and talk to some of the people working on the James Webb Space Telescope, and then bring that information back to the students I work with here and to the community at large here, or to write articles about it to kind of share the awareness of the mission coming up and whatnot. So it's kind of my relationship with that project is more of an outreach kind of educator.
Mm-hmm. Okay, we do have like kind of comment or question for you. It's from Sarah.
Okay.
She say, hi, here in Tunisia, science in general and astrophysics, cosmology, astronomy in particular are not given as so much importance in school as they should have, so kids grow up generally with lack of knowledge and or interest to the whole subject. In your opinion, how do you think can we introduce this into education? Of course, without waiting for the government to do so. Thank you very much for the lecture.
Yeah, it's a great question. I don't think there's one correct answer for it. I think it's what works for your community and the age groups that you'd be working with. So I'm lucky in that I get to work with students at the preschool level all the way up through high school and college. So we have several different programs depending on the age group that we're working with. But I find that just trying to offer programs that are going to raise the kids' natural curiosity and interest. So if it's a demonstration, if it's a chemical reaction demonstration, one popular one I do is I have pieces of, I wish I had one here to show you, but I have pieces of Kevlar, which is the white material on the outside of a spacesuit. I'm sure a lot of you have seen a picture of spacesuits with either astronauts walking on the moon or working on the outside of the space station. And I have an engineer that provided me some of that Kevlar material. And Kevlar, one of the qualities of it is it won't catch on fire. So you can make it into clothing. It's in the outside of the spacesuit. It's that white material. And so I'll have a swatch of it, and I try in the demonstration to set it on fire, and it won't burn. And that gets a lot of the kids, younger kids, excited and interested because they're like, why won't that catch on fire? You're putting fire all over it. It has to catch on fire. So we talk about that, and then that's easier to get the kids excited about the science or the chemistry or the chemical part to it. So depending on the age group, I think that the biggest key is just to get them interested, get them excited. Instead of it being a lecture or here's your homework or here's what you should know, it's trying to find a way to pique their interest, to get them leaning forward, to get them asking a question or get them excited. So that's what, as an educator, what I just try to do, no matter what age group I'm working with, what's going to give the kids that kind of wow moment, and then I'll start with that, and then usually the interest and all the questions follow pretty quickly after that.
Mm-hmm.
Hi, I have a question.
Oh, is your mic muted? I didn't hear it.
What's required for the to be an intern at NASA, and is the American citizenship required for most of its programs?
Internship can start all the way at the high school level. I work with students here at the local high school. So for juniors and seniors in high school, 11th and 12th grade, they start with internship programs that you can do over the summer. Usually when kids are out of school over the summer, they have summer internship programs. And then that continues on. There are internship opportunities for college students that are taking a like degree, in engineering, electronics, physics, chemistry, astronomy, internships for entry college all the way through graduate school. And then, yes, unfortunately, it is like the other programs where there's usually a U.S. citizenship component. If you are an exchange student to the United States on a program, that can provide some opportunities for internship that way. And then there's other countries that have students that come over for internship programs where they're doing a similar thing in their country. Like I know of some students that were interning for the European Space Agency. They did some internship with certain NASA centers in the United States and went back to their country, the European Space Agency, to continue their internship there.
Thank you.
Mm-hmm.
Hi, Christopher. Thank you for this lecture. It was very interesting. So, actually, in Morocco, they have been organizing some kind of collaboration between US Embassy and NASA, and they train some high school students. It's a competition called Race to Space, and this is Very interesting, actually. In Morocco, we've been working on trying to share this astronomy and astrophysics passion to all the publics, and actually we have a lot of association and clubs. One of the raised questions is there any ideas if there is a purpose to extend your outreach activity to outside of US? Kind of, are you open to collaboration with other countries or something like that?
Yeah, that's a really great question that you mentioned, especially at this time, because with the COVID-19 issue, with everybody being kind of under stay-at-home orders and things being kind of restricted for movement and whatnot, I've had a lot more requests for programs outside of the United States like this and others that I've been able to participate in. So I've been kind of researching if that's something that'll continue going forward after things kind of return to normal. So I'm very supportive of it. I think that the international community it works better when there's more collaboration with different opinions and different voices, different people. So I'm very interested in continuing it and finding out ways to collaborate with other people. I've gotten a lot more friends just on social media from different countries through this process of finding about what they're working on and collaborating with them on other ideas. So if there's a good thing to come out of all this, I think that's been one of the best things for me personally that's come up is just making a lot more friends, hearing about a lot more things that are happening around the world and different opportunities and what students are working on in other countries and how I might be able to adapt that or use that here and whatnot. So I'd be very open to continuing this moving forward. As far as if it would be just through my nonprofit or if it would be through some kind of NASA program, I'd have to find out NASA's stance on that and what they want to do in those regards. But I can just speak my personal Space St. Croix, my educational nonprofit I'd be very happy to continue the dialogue and continue helping people any way I could just with my personal organization. So yeah.
That's good. Thank you so much.
Oh, yeah, thank you.
What kind of encouragement should we say to the youth or for kids to go forward and study astronomy, let's say?
I think it just, I had a similar question from a teacher that was a history teacher, and the history teacher's just like, I get what you're saying, Chris. Well, how does this apply to me or to my students? I was saying, I think scientific literacy and kind of approaching things in a scientific method, scientific testing, I think kind of organizing your brain in that way is good for no matter what you want to do, what career you want to work on. And I try to start some programs that way, not saying that everybody here should be a scientist or want to work for NASA or run out and buy a telescope after this program is over. But no matter what you're into, I think scientific literacy, the scientific thought process, being open to disagreements, conflicting opinions, testing, validating your proof. I think those are all good things. And some people aren't familiar with that way of thinking or conducting yourself. And I think introducing people to that can be beneficial, I think, to your life no matter what you do or what career you're in. It can be helpful for kind of organizing your brain and organizing how you want to approach a problem, a personal problem or a work problem or whatever it is. So I try to pitch some of my programs that way, that even if you never get into a science, technology, engineering, or math career, if you work in a completely different field, I still think you can get a great benefit in kind of understanding the scientific method and those practices. So that's kind of my pitch that I make for some people that it may not apply directly to them.
Mm-hmm. What is the most interesting experience that you had working with NASA? Yeah, the most exciting experience, what it was.
Okay. I had one about 2 years ago. I didn't include it on this slide presentation because my focus was a little bit different for this, but about 2 years ago, I was a speaker at the NASA Johnson Space Center in Houston. They have an educators conference, and I was a speaker there. And they try to show us around a lot of facilities there when we're not speaking or presenting or attending other speakers. And one of the days they took us to an area what they call their Mars yard. They have a moon area and a Mars simulated surface area. And they have a new rover called the Space Exploration Vehicle. It's an enclosed, pressurized rover, and it has 6 sets of wheels on it, 2 wheels for each. And each set of wheels turns 360 degrees in rotation. So if you can picture that, the car, they let us take rides in it, they let us drive it for a while, but they have little hills there, and they could drive up sideways on a hill, do a 360 degree turn, and then go down diagonally on the other side of the hill, drive it into craters on the moon side, you come up sideways. So it was a very surreal feeling. You feel like you're going to tilt and fall over, but they have hydraulic actuators that kind of keep it balanced, keep it level on the wheels. But I did not know they would let us drive a multi-million-dollar experimental rover design for going to the moon or Mars. And, so that was pretty exciting afternoon to spend at NASA.
Yeah, I can imagine.
Yeah.
So there's someone asking for your email. He said if he could get your email.
Oh, sure. I can send that to you, or I think that might even be available on my my Facebook page and whatnot. So you're free to share that, or I'll be happy to send you that if it's not there after we're done here. You can share that.
And if it's possible to get your presentation, can we get a copy of it?
Yes. The slides I showed today, I could be happy to send you that by email as well. If you'd like to have that.
I don't know, guys. Do you have other question to ask for Christopher?
Yeah, I just made Mesa told you about this initiative of online people that's following different Facebook page in different countries in Zoom. Well, I would like just also to extend this to the outreach stuff if they want to give it. They want to participate with some who you do now.
Yeah, I didn't hear every part. It was cutting out a little bit, but I think the gist was you were asking about sharing with other groups and whatnot, and I'd be very interested in talking with you on that if that's what you're asking.
Yeah, exactly.
Okay. Oh, sure. Yeah.
Thanks.
So, we have other question for Christopher? Okay, from our side, we don't have any more questions. So let's thank Christopher Meek again for the nice talk. Thank you, Christopher, for the nice talk, and thank you to be with us tonight for the AstroTalk project. So have a nice day there, and yeah, thanks a lot again, and see you the next time. See you. Bye bye.
Okay. Bye bye.
Bye bye, everyone. Bye bye.